1st or September 2nd. Objective 1.7, translate among the forms of a linear function, and 1.8, translate linear functions. First, we're going to finish up 1.7 here. So switching between forms of linear functions. So far, we've done from an equation to a graph. We've gone from a graph to an equation, and we've gone from a series of points to an equation. Now we're going to go from a verbal description to an equation. Example number 1 says, Fluffy the dog was born weighing 2 pounds, and each month she grows 3 pounds heavier. Define your variables and write an equation to describe Fluffy's weight in terms of how many months old she is. The important thing here is to define your variables first, x and y. Now you can use any two letters, but I like to use x and y. And when you think about variables, you're thinking about what two things in this situation are changing. If the dog was born at a certain weight, and then as she gets older, she grows in weight, the two things that are changing are the weight of the dog and how old the dog is. So weight and age. Those are the two things that are changing. We need to decide which one goes in x and which one goes in y. The x, remember, is the independent variable. It's the one that changes on its own or changes not in relation to the other variable. Usually, if you have time, of which age is part, that's going to be your independent variable. So in this case, the age of Fluffy in months is your independent variable. And always remember to include units in that. If that's our independent, then our dependent has got to be the weight. So Fluffy weight, so Fluffy's weight and the units are pounds. Now we need to write an equation. It's best to write it using y equals mx plus b. We know that this is we're always going to have an x and we're always going to have a y. But the things that are going to change are the m and the b. The b is the starting point. So that's the initial value. In our case, the Fluffy started out weighing 2 pounds when she was born. That's how much the dog started out weighing. So plus 2 will be our starting point. We always know we have the x, and we always know we have the y. The other one is the m, and that is the slope, or rate of change. How fast Fluffy's weight is changing in relation to how many months old she is. The key words that tell you that something is a slope are per, each, or every. All of those say, hey, this is the slope. And if we read through, we see that in our problem, each month she grows 3 pounds. So that tells us that 3 pounds is our slope. She's growing 3 pounds, so that means we're going to want to add 3, or a positive 3. So 3x plus 2 is our final answer. On the next one, a tree is planted when it is 18 inches high. Each year it grows 32 inches. Define your variables and write an equation to describe the height of the tree in terms of how old it is. Again, our variables are x and y. The two things that are changing in this are the height of the tree and the age of the tree. Again, we want to take the one that changes on its own, which is usually time if you got it, so age. The age of the tree in years. That's our unit. And then the height of the tree is our y in inches. In inches there. When we write our equation, we start with y equals mx plus b. B here, remember, is our starting value. We always have a y and an x. B is our starting value, and the tree starts out, is planted when it's 18 inches high. So that's plus 18. And then our slope, the m, we can see that each year it grows 32 inches. So 32 is our slope. That's your answer. With number 3, your friend is standing 200 meters away from you and starts running towards you at 5 meters per second. Define your variables and write an equation describing the distance your friend is away from you in terms of the time since he started running. The two things that are changing, time since he started and the distance between the friends. So time and distance, x and y. Again, time is usually your x variable. So the seconds since he started running is our x, and our y is the distance between friends. There we go. Again, y equals mx plus b. We always have an x, we always have a y. Our intercept, what is the starting value? Well, you start standing 200 meters away. Oh, in meters. Got to include that unit. So plus 200 meters away. And then the slope. Look for per, each, or every. And we see per right here, so meters per second. And he's running toward you at 5 meters per second. If the person's running toward you, that means the distance is decreasing at 5 meters per second. So we want to put -5 in there for our slope because the distance is decreasing. And that is our answer.